Oops. Welcome, everyone. Welcome to ESSA. The recording is in progress. It's just told us. For those of you who don't know me, I'm Andrew Luke, and I am standing in for Chris Dykes, who's our chairman, but he's off on a trip at the moment. So I'm going to host us tonight. But just quickly, some of the things that we've got coming up. We've got quite a busy couple of months coming up, and our first thing is it's too late to join it now, but Chris Dykes is on the Kruger Trail. He's walked the whole length of the Kruger over the last few months, and he's on the very last leg from Lower Sabi to Crocodile Bridge. So that's a great trip that he's on, and he'll be giving us a talk about that in the upcoming months. But the next thing that we've got, which is an ESSA staple, one of our signature trips, we've run it for years, is our stargazing and Poiki competition. So that's run by Mariam. It's out at Bushtrails in Magaliesburg. We do it in conjunction with ESSA, the Astronomical Society, and that's been a great trip for many years. Please come and join us. It's a good way for beginners to get to know our club, to meet ESSA, and it's a lot of fun as well. Okay, and it's Bushtrails in Magalies. So on the 22nd of July, and we stay overnight because the stars tend to come out at night, and then so we'll have a breakfast on the Sunday as well. Okay, so that's a good one. I think the next one that we've got coming up is Suikerbosfontein hike. That's in Mpumalanga near Machadodorp. That's organized by Pierre. That's the 25th to the 27th of August. That looks like it's going to be a great hike. So please come and join us for that one. Some of the other ones that we've got coming up then is our formal dinner, which is also an ESSA signature trip, a staple trip. That's where you get dressed in your finest, you eat off your grandmother's inherited crockery and cutlery, and we go to an exotic place for our formal dinner. This year it's out on the Num Num Trail, the whole Num Num Trail, and that's on the 3rd to the 5th of November. So please come and join us for that. That's a lot of fun. It's also a great way to introduce yourself into the club if you haven't been part of it as well. Okay, I think those are some of the big trips coming up, but please have a look at our website. Please make sure you're on our WhatsApp group. Have I left anything off? We've spoken about that, and we've spoken about the Poiki as well. Right, so in preparation for our stargazing, together with ESSA, we are very lucky to have Alison Coulter with us. She is part of the Astronomical Society of Southern Africa. We've met her on our previous trips out there. We're very excited to have her back here, and I'm going to hand over to her to take us through a presentation. Cool. Let's have a warm round of applause. Over to you.
Cool. Thank you. I might stand because I like to gesture when I talk. So let me just aim in the camera so you guys can see me. Yeah, all my show and tell goodies over here. You guys guys online, you must just shout if you can't hear me. Yeah. Cool. Cool. So thank you for the introduction. It is an absolute pleasure to be here. I love talking astronomy and how to get started in astronomy. So this is an absolute pleasure. Thank you. So for those of you who don't know me, my name is Alison Coulter. I'm the treasurer for the Astronomical Society of SA. And I also call myself an amateur astronomer. Amateur does not mean I'm bad at it. Amateur just means that I don't get paid to do the thing I love. I'm sure you guys also know this very well, being amateur explorers. So the topic that I'm going to be discussing today, and I've been chastised by a few people on this title, How to Astronomy. I do it deliberately to get a rise out of people. And what we're going to be talking about tonight is observational astronomy, because astronomy is an enormous topic. It ranges from everywhere from how to operate a telescope, to astrophysics, to cosmology, which is the study of black holes and dark energy and dark matter, to astrobiology and all that. So we're going to be focusing tonight on observational astronomy. So a quick little recap in case you forgot your geography. We've got our solar system, which is the Sun, Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, Neptune, and the fourth planet, Pluto. One thing that a lot of people don't know is Mercury and Venus can show us phases, because they're what we call the inner planets. So they're between the Earth and the Sun. So they will always be in phase. So we always see their backsides. So when you're looking at Venus in a high power telescope, especially now, we got the privilege when we went to Boyden Observatory, we can see that Venus is this beautiful crescent shape at the moment. And because Mercury is also very close to the Sun, you will never see Venus and Mercury past sunrise or sunset. They will always be with the Sun. But the outer planets, so everybody from Mars out until Pluto, you'll never see them in phase because they're on the other side of the Sun. So we are always seeing them as the Sun is shining directly on them. Mars you might see to a certain extent because it is closer to us, but the outer planets you'll never see in phase. You'll always see them full on. So that's something a lot of people don't know, which is quite interesting. So I'm sure you guys know this. I give this presentation to people who've never looked through a pair of binoculars before, but I'm sure you guys are quite familiar with latitudes, and that Johannesburg is in 26 degrees south. Cape Town is 33 degrees south. This is important because when we are looking at celestial objects, there are certain objects we cannot see, which would be everything in the northern hemisphere, or most of the objects closer to the North Pole. I don't think I need to show you. So you understand angular distance and how latitudes work. I'm sure, being explorers, I'm sure you use maps. So this means because of our latitude, we're being 26 degrees south of the equator, we'll never see the Big Dipper or Polaris or any of those, the Pole Star or any of those things. So that's one thing we need to keep in mind when you're doing any Google search for celestial objects. You have to always put Southern Hemisphere in your searches, or when you're looking for star atlases, you make sure that it's specific to the Southern Hemisphere. But doesn't mean that all is lost, because we can see we are beautiful celestial objects that are exclusive to our hemisphere, such as the Southern Cross, the Eta Carinae Nebula, Alpha and Beta Centauri, Proxima Centauri somewhere there as well, Omega Centauri, the large and small Magellanic clouds, which are known as diffuse galaxies. And then, of course, we get the full view of the center of the Milky Way, which is pointless. So I'm going to just briefly touch on some astronomy terminology. It's just terminology that we use, in some jargon that a lot of people are not aware of. So what we have here is what's called the celestial equator, and it's basically the Earth's equator projected outwards. So if you had to imagine that the Earth was enclosed in a glass ball, and there was a light shining from inside the Earth, the shadow of our equator is what's projected onto that glass ball, so to speak. And then you get what's called the ecliptic. So you can see that the celestial equator is in line with the tilt of the Earth, but then you have the ecliptic, which is, always forget this definition. It's the great circle on the celestial sphere that represents the sun's apparent motion in the sky. And one way you can tell if the object you're looking at is a planet or a star is if it follows the path of the ecliptic. So if it follows the path of the sun and the moon, and if it's near sunset or sunrise, or if it's quite bright and it doesn't blink, it doesn't twinkle, most probably a planet. So if it's around sunset, sunrise, it's probably Mercury and Venus. If it's later on in the night, I know in winter now, Saturn will be rising at around 9 in the evening. so it will probably be Saturn, and it looks like a small yellow star. Jupiter will be rising much later, at around 2 o'clock in the morning in winter, and it will look quite a bit brighter. So, but if they follow that path, chances are it's a planet. And then we get zenith and nadir, which zenith is being the top of our celestial circle, which marks north to south, and the nadir is at the bottom. And then the meridian is the line, the invisible line that crosses north to south. This is quite important to know if you have what we call an equatorial mounted telescope, and you need to align it to the poles so that when it's tracking, it can follow the motion of the Earth. But I'll explain what that is later. Okay, and then just another little bit of terminology is magnitude. So magnitude is how we measure the brightness of a celestial object. But because astronomers, very much like the mirrors in their telescopes, like to work backwards, so the larger the number, the fainter the object is. So in Johannesburg, we can see maybe down to magnitude 6 on a clear winter night. Might be a little bit worse now, will probably be more likely magnitude 4, because the light pollution has gotten considerably worse in, I'd say, the last 10 years. But in your dark skies, I mean, this can go right down into the early teens. So you can really see like the faint objects just with your naked eye.
Load shedding helps.
Load shedding does help a bit, but the problem is the load shedding is patchy.
Yeah.
So you'll have one suburb that's out there, but then it's like blazing stadium, Ellis Park. Right next door.
Blackout.
Yeah. And then of course now everybody has solar, so it's like, everybody keeps their garden lights on. So this is just a lovely chart I found on sort of gauging how bright things are, so that you can see the sun is very bright at -26. Full moon is at around -12, -13, and then Venus at its brightest is also just very bright. It's around just under -5, and then you can see as it goes down, 1 meter telescope limit means a telescope that has a lens diameter of 1 meter, and then all the way up to, I mean, it's Hubble's limit is about 30. James Webb will be more sensitive. I mean, I need to update this, but just you can just get a sense. So one thing we do need to talk about is in ESSA and in astronomy circles, there is a phenomenon known as Hubble Syndrome. Now, because of the advances in technology and these beautiful pictures we're getting from James Webb and Hubble, it's that feeling as you get up to the eyepiece and you look and you're expecting to see the bright reds of Orion Nebula, and you look and you go, is that it? So we always say to especially people who've never looked through a telescope before, lower your expectations. And yeah, so as I said, it's because of these beautiful astrophotography images that we are getting. And also astrophotography has now become a lot more accessible and a lot cheaper and a lot easier for people to do. So it does give you this false sense or this false sort of hope as you buy your first telescope, you're expecting to see the beautiful like reds and greens of like Eta Carinae, and then you just see this faint gray smudge. And it's because that your eye can't do long exposure shots. Your brain can't freeze time. And also your rods and your cones in your eye are not as sensitive to color in the dark. They're sensitive to contrast, to light and dark, but not to color. So most objects you'll see, nebula, and certain stars and stuff will come out as your faint and fuzzy smudges. But that's what we get excited about. So it's about being excited to see the faint gray smudge. So just an example, this is a beautiful photo. This was NASA's picture of the day of the Dunkard Nebula, M27, which we can see from the southern hemisphere. And you can see the beautiful reds and beautiful blues. So expectation. and reality. And even this is pretty bright. It will not be as bright in your telescope. But one thing that we remind people is when you're looking into the scope, those photons coming from that object are landing in your eye in that moment. You are seeing that in real life. That is not AI. It's not generated. It's not a photo someone's manipulated. That is real. So
all the colored ones are
photo manipulated.
Yes.
They
Filtered.
filtered, and it's also long exposure shots. When we went to Bloemfontein Star Party about 2-3 weeks ago, one of our members, our curator of instruments, brought his camera, and he managed to set his very fancy equipment up, and he took a photo of Eta Carinae, and he exposed it for about 30 seconds, I think. It's quite a long exposure. And then as the photo came up, just suddenly there's all these reds of the nebula just came through. It was like overwood. So yeah, long exposure for photography, different kinds of filters. And what a lot of people do is they stack the photos on top of each other and, you know, work with Photoshop magic. So it exists, but it requires computer assisted machine work.
And then you really prefer looking at the
I do.
smudging.
I do, because it's sort of like bird watching. I sort of liken astronomy and bird watching. They tend to be like the same kind of people, except our targets don't suddenly bugger off as we put our scopes to them. But you know, you see the bird in the Sassel, bird guides and whatnot, and it's like, you know, they take these fantastic photos, and then you see the bird in real life, and it's drab and it's wet and it's raining or whatever. But it's still special to have seen it yourself. You get that sense of achievement, that sense of satisfaction. So what a lot of people ask us, so I want to get into astronomy, where do I begin? By looking up, preferably at night. And by having a pair of eyes, preferably two, but one will do as well. And a dark sky, good weather, and timing. So we work on a scale called the Bortle scale, and this is a measure of sky brightness. So you will see that number 1 is an excellent dark sky site. That would be out in the Namib Desert. It would be out in the Northern Cape, the Karoo, out where sort of Sutherland area. And you will see so many stars you won't even be able to find the constellations. Then you get all the way up to portal 8 or 9, and that's basically the inner city where the sky is almost like daylight. In Johannesburg, we are around a portal 6, portal 7 near the observatory, portal 6 to maybe a 5 during load shedding in the suburbs. Magaliesburg, you can get right down to about 4 or 3, 2 if there's load shedding. So cross fingers, we have some good viewing on the 22nd. And then yeah, so like the further away from the city, the better. So always a good excuse to go away on a holiday, go away on adventures. And then obviously good weather. So astronomy is not for those with a large ego or little patience. Nature does not care. If you bought your nice fancy scope today, it will rain. Like today, I purchased myself a solar filter because I want to start taking images of the sunspots. And my eyepieces arrived today, and of course it was cloudy. So I have to wait. But in Gauteng, I'm not 100% sure about the other provinces, but I know in Gauteng, winter is the best time to do astronomy. So that's why we've been at ESSA, we've been very active with our stargazing evenings, and Magaliesburg, we get nice clear weather. And that's also where your weather apps become your best friend. And then, of course, timing. So winter skies are darker than the summer nights. So the air is colder. You get less, it's less volatile. So you get less of that shimmer. There's less chance of rain. And then certain constellations are also seasonal. A lot of people don't know this, but the Earth orbits around the sun. The picture of my face is nighttime. As it orbits around the sun, it will be facing a different part of the universe. So there are certain things such as the Orion Nebula, we will only really be able to see that in summer up until late autumn. Now is the best time to look at Scorpius, which is also a very nice, very easy to find constellation. Southern Cross, even though Southern Cross can, from our perspective, can be viewed all year round, wintertime is best. And then, of course, if you want to do some deep sky viewing, moonless nights are the best because your moon is very bright and it will wash out all your faint and fuzzies. And as far as I know, I think the 22nd is around new moon anyway, so it's a good time. Cool. And then just a couple of tools to help you. I did bring some show and tell things here. Always handy to buy yourself a planisphere. I think I bought this from Take-A-Lot. So this shows you what the sky will look like at certain times of the year and at certain times of the night. So we're in July. So if I want to see what's currently up in July at around 10 p.m., I just turn it. So see the little dial there. And then if I want to look, so this is north. I want to look at my northern sky. I can see that Boötes and Cygnus is up and Orpheus is up. So those are the constellations. You can see because we are further south, the southern sky is bigger than the northern sky. And we also got some very nice constellations up. And then I'll know at around 10 o'clock, this is going to be up. If I want to ever see Andromeda, you just have to spin it around and see whereabouts it is. Very, very handy, very, very useful tool. I highly recommend buying one. And cheapest chips as well. Star charts are also very good tools to use. So they tell you exactly in each month, you know, what's happening, you know, what you can expect to see. As far as I know, the Wits Planetarium are still publishing them on their website. They haven't put the one out for July yet, but they have been every month they print one or they publish one. So very nice. And then, of course, there is our Sky Guide from ESSA. If you become a member, you get one for free. But you can buy these from exclusive books as well. And these will tell you, like for July, see what's happening on certain days at certain times of the night. And then the Celestial Almanac as well. So what the planets are doing and so on and so forth. But then, of course, there's nothing stopping you from using an app. There is no shame in using them. It's not cheating if it rewards you. My personal favorite is Stellarium. I have it has a desktop version available for free. It's open source. And I paid for the one on my phone. 100% worth it. I use it all the time. And then Sky Safari, Star Walk, and Sky Tonight. Those are our members' favorite ones. I'm not too familiar with them, but they speak very highly of them. And they're great for if you want to plan a stargazing session for that night and you can sort of see more or less which stars you're interested. I keep a star diary, so I'll show it to you here, of objects that I'm interested in finding. So for example, my next target object is the southern pinwheel. And as you can see over here, the camera, I've marked which objects that I'm very familiar with, and then the stars nearest to it, so I can start help towards it. And I used Stellarium to help me with that. So 100% I endorse. Okay, so I'm sure you guys are all dying to know, what can we see? So I've split them up into various sections: naked eye objects, binocular objects, small telescope objects, and large telescope objects. So of course, the most obvious one being the moon. Moon is a very, very nice object to look at, especially at certain times of the month. You can see that the second one from the top, that's actually a new moon, but I managed to catch the Earth glow. These are all pictures I've taken, by the way. You can see the Earth glow on the moon, which was quite nice. And then obviously, I'm sure we all remember the lunar eclipse that we had a couple of years ago. I mean, the total lunar eclipse, that really was something. Then, of course, there's the International Space Station. It does pass over Johannesburg. There are websites and apps that can tell you when it's passing over. It usually comes over in the southwest direction at around 6 to 7 to maybe 8 o'clock in the evening. So when the sun is shining on it. And it will look like a bright, fast-moving star. And I'm pretty sure it's the objects, you know, because we do sometimes get emails saying, "Are there aliens? I saw an object." It's the International Space Station. I'm sorry to break your heart. And what's really nice about this particular object is if you look at it through a pair of binoculars, you really get a sense of the 3D-ness of the space behind it. You can see the parallax, and like suddenly the Earth is not just a flat dome with holes poked into it. It's you know, the sky. It feels real. Then of course there's our constellations. Obviously the lines won't be there. And I'm going to show you two constellations that are not winter constellations. These are known as summer constellations, but they're lovely ones because they're very easy for even kids can find these. And it's one that a lot of people recognize. So this is our good old friend, the Orion constellation. You can recognize it very easily by the three little stars that make up his belt. It has a beautiful nebula in his sword, the Orion Nebula. It's a personal favorite of mine because it was the very first nebula that I spotted and identified all by myself. And it's very distinct. And it's also what's considered a stellar nursery. So stars are born in it because it's very hot and it's very like volatile and yeah, and then there's also with you can obviously confirm it with Beetlejuice or Beetlejuice. The jury's a bit out on the pronunciation. And Beetlejuice has been an interesting object for astronomers because there was that recent period where it went dim and we thought it was going to go supernova. But the current hypothesis is that there might have been a gas cloud that passed in front of it that caused it to dim very briefly. But now it's sort of back to its usual magnitude. But it is what's called a red supergiant. So it is expected to go supernova. In astronomy, they take the South African sort of saying very literally. It's either now, or just now. Now could mean it could happen right now. Now is in the next 10 years, and just now in the next 1,000 years. So we don't know. And then another very nice summer constellation is Canis Major, or the Greater Dog. And the reason why I like this particular one is that it's right next to Orion. And the two are often called the hunter and his dog. And you can identify Canis Major by Sirius, the dog star. If there are any Harry Potter fans, I'm sure you'll recognize the name Sirius. And Sirius is a binary star, very interesting binary star. Its secondary is called the pup. So it's the dog star and his pup, which is very, very difficult to split. But if you can, she's good for you. Yes, it's one of the brightest stars. Yes. So now we get to our winter constellations. This is a good old Southern Cross that is unique to Southern Hemisphere. Very easy to identify with the cross. It is one of the smallest, it's the smallest of the 88 official constellations. And very easy to identify. And most of us in ESSA use this as our reference point when we start star hopping. So if we're wanting to go to, for example, the Centaurus Galaxy, which I will show a bit later, we always use the Southern, you start at the Southern Cross and then you hop, 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 hop. And there's a very, very nice open cluster on here, so people online can see. There's a very nice open cluster next to Mimosa over there, called Herschel's Jewel Box, which was discovered in the Cape of Good Hope. And it's identified by, it's a cluster of stars with one red supergiant in it. Very, very, very nice. Very easy to see in a pair of binoculars. Oh yes, and then of course, it's right inside the Milky Way. So where I've circled there is what's called a dark nebula, the Coal-Sack Nebula. So it's a patch of gas and clouds that are obscuring the light that's coming behind it. And it's also a very nice one to see, pick up in a pair of binoculars. Okay, then we have the Scorpius constellation. Again, it's a very, very nice one to spot. Very easy to identify because of the curl in the tail. And then you confirm it with the red supergiant Antares in the middle. Because it's quite close to the center of the Milky Way, or to the Milky Way, it's got quite a few interesting objects, such as the butterfly cluster, Ptolemy's cluster, and a few globular clusters, which I'll get to in a moment. And then, of course, there's the Sagittarius constellation, which contains the asterism, the teapot. So if you can spot the teapot, you can spot Sagittarius. In a particularly dark sky, you can also see the portion of the Milky Way rising from the spout. So it's almost like it's the steam rising from a hot kettle. And because it's closest to the galactic center, it contains the supermassive black hole Sagittarius A star. And we always put the asterisk there and you pronounce that star. So it's as Sagittarius A star. Okay, so what can we see with a pair of binoculars or a small telescope? Omega Centauri. Now, Omega Centauri is what's known as a globular cluster. What is a globular cluster? Well, it's a spheroidal conglomeration of stars which are bound together by gravity, which is science for a block. Little is known about how globular clusters are formed, but the current hypothesis is that they originate from a single molecular cloud or a stellar nursery, which makes many of its stars very similar in age. And we think Omega Centauri is it contains some of the oldest stars in our galaxy, if not in our observable sort of group. So it's the largest globular cluster in our galaxy, and it is so dense that it's estimated that the stars inside it are about 0.1 light years away from each other. Now, for reference, our closest star, Proxima Centauri, is 4.25 light years away. So you can only imagine how close they are, how much gravity is happening there. So, and also what makes this particular one very interesting, apart from it being bright and very easy to find, is that the current hypothesis in astronomical circles is that it's the core remnant of a dwarf galaxy that was absorbed by the Milky Way. So we're seeing the leftovers of it. And yes, and in dark sky sites, you can see this by naked eye. It will look like a fuzzy star that just won't focus. So there you know that's Omega Centauri. It's a beautiful one in a telescope. So how do you find Omega Centauri? You will pick up the 2 pointer stars, Rigel, Kent, and Hadar, and then you will star hop to Epsilon Centauri, which is to your right, and then you will see the blob. If you just carry on going right, I like to try and go in straight lines, up and down, left and right. Other astronomers will use the Southern Cross and then navigate. They'll either use the 2 pointer stars in the Southern Cross and draw a triangle. But I like to take my scope and left, right, up and down. So that's how you can navigate. Another good technique, if you want to be more precise, is you can use your fingers. Because we measure the sky in degrees. One form of measurement is in degrees. And your index finger is about 1 degree across. So it can cover the sun and the moon, which is about half a degree across. Either a closed fist or an open hand, that's 10 degrees across. And then if you make this sort of surfer sign, that's 15 degrees across. So if you are and this is with an outstretched arm. So if you're trying to explain to somebody how to navigate, and you prefer to use your hands, it's a very good way of doing that. Then there's an Eta Carinae Nebula. Now, this is both a nebula and there's the Eta Carinae star inside it. So it's about 8,500 light years away. And what makes this nebula very interesting is that it's 4 times larger than Orion Nebula. And it has there's a lot of smaller nebula happening in it. very, very large nebula, so you don't need a high-powered scope to see it. In fact, I would recommend using a pair of binoculars to look at this object in a dark sky. Beautiful, beautiful object. And then if you were to use astrophotography on it, you'd be able to pick up the reds of the hot hydrogen gas in the stellar clouds. So all these images I'm showing you here, I've tried to keep them as realistic as possible. So they're not the beautiful Hubble images, but what you would more likely expect to see when you're stargazing. So this is a very nice one. And you can recognize it because it's fairly close to the Southern Cross. And you can confirm it with the dark patches of clouds. It almost makes like a Y shape. I call it the Y front of the clouds. And how do we find it? So you would use the Southern Cross, and then the two edges of the cross, Acris and remember that bottom stop, and you would make a triangle and go straight down. And you would just follow the Milky, and you can also just follow the Milky Way straight down.
So is that in perspective in terms of size?
It's what?
Is it the size?
Yes, it's massive. It's huge. Yes, yeah, I took this from Stellarium. Okay, and then of course you can take with small telescope close-ups of the moon. This is an image. I just held my phone in front of my eyepiece and took that beautiful picture. The moon is best seen, if you want to ever image it, best seen around new moon. So then you get the crescent, and then at first quarter. Anything past first quarter, it does get very bright. And we find it best around first quarter because then you see that contrast of the dark and the light sides. Then, of course, you've got your planets. As I said earlier, I think Saturn is expected to rise at around 9-10 o'clock on the 22nd. So hopefully we'll get some nice viewing of Saturn. Jupiter will be up much later, like if you're willing to stay up until 2 or 3 o'clock in the morning, but also very, very, very special to see. And then, of course, you'll know what you're looking at through a small telescope. Saturn will look like, you'll see the distinct disk shape, will look like a stretched out star. And then Jupiter, you will see its moons. In a high-powered telescope, you'll then be able to you'll see the red bands across Jupiter. I've been able to see the red spot, the Great Red Spot. The unfortunate thing with the Great Red Spot is that it is receding. It is getting smaller. So catch it now while we still can. And with Saturn, we sometimes use Saturn to calibrate our telescopes as well. If you can clearly see the Cassini gap between the rings, so if you see the one ring and then the larger ring outside, you see a black band in the middle, and you can see it clearly. Then you know your telescope is set up properly. Then we've got our open cluster. I mentioned the butterfly cluster. Very, very, very nice one to see in a small telescope. It's found just to the left of the stinger of Scorpius, and it looks like a butterfly. You can see it looks like a butterfly to the side, and you can see the middle stars make up its body. And open clusters are found usually only in spiral and irregular galaxies where active star formation is occurring. Very, very nice one. Very, very beautiful one to pick up. And of course, this is how you find it. So you see where Scorpius's tail is curling, and you'll pick up the two stars at the end, and you'll see the star. There's a star to the bottom left, and you almost draw a triangle up to it. That patch of stars next to it, I forgot to highlight it. That's Ptolemy's cluster. It will look like a square with lines coming off it. You'll know it the moment you see it. Good job. Butterfly cluster is just there. Then we get what we call an asterism. So this is Brocchi's cluster, or the coat hanger. Also very, very nice one, because the moment you see it, you know immediately what it is you're looking at. What is an asterism? I'm sure you're asking. An asterism is a pattern of stars that are found inside a constellation, but they're not part of the official 88 constellations, even though constellations are based off of asterisms. So an easy way to remember the difference is that the constellations are big and they divide up the sky into sections, whereas asterisms don't. But they may be housed inside a constellation. So the coat hanger is one of them. And how you find it, this is a little bit of more of a challenge to find, but very satisfying when you do. You find the very bright star Altair and Vega, and you draw a line right between the two of them. So if you are able to navigate your scope, your binoculars across, it will be right in the center. Again, I like to navigate in straight lines. And then a very, very nice nice cluster that I was introduced to fairly recently is called the Stargate Cluster. This was named after the TV show. It's just to the right of Corvus, and you can identify it by, it looks like a right side up triangle with a small upside down triangle in the center. And we sometimes use this particular one to judge seeing conditions, because if you can see that small third star right in the middle there, then you know your seeing is good. And this is how you find it. So if you can find the constellation Corvus, which is in the north, it's in the northeast, I think. You see the square of Corvus, and then it will be just to the right of it. Corvus is a nice one to try and find and identify, because there's a very interesting galaxy right next to it, right next to the asterism itself, which I'll get to just now. Then, of course, you get your larger telescope. So we consider a large telescope anything from 6 inches upwards. See, that's my personal one. You can see planetary details. So as I mentioned earlier, you can see the bands of Jupiter, and you can see the little dark patch of Mars. These are my photographs. I'm not an astrophotographer, as you can see. So these look a lot nicer in the eyepiece. But it's just to get a sense of, it's getting a larger scope. Very, very nice. And then also one thing you need to start if you're considering using a larger scope or purchasing a larger telescope, is start paying attention to your eyepieces and the quality of your eyepieces. But I will, because that can make or break your viewing experience, but I will explain all of that how to buy a telescope. Large telescopes, it depends on how large you go. But I'll explain, because you get different types of telescopes as well. But I'll explain, there's 3 main types that you get, and then I'll explain the advantages and disadvantages of each. Then, of course, you get your binary stars, which are also very nice to try and split. Very well known one is Alpha Centauri. And binary stars are interesting because they orbit, it's the primary and the secondary orbits around each other. So it's a very nice, if you want a bit of a challenge, very nice one to try and split. And then the galaxy I mentioned just now is called the Sombrero Galaxy, M104. So it's found next to Corvus. And what's very nice about this one, it's fairly bright. So it's actually a fairly easy-ish one for beginners to try and find. And there's a supermassive black hole in the center, which is of particular interest to professional astronomers. So at about magnitude 8, you should be able to see it even through a medium-sized telescope. And again, that's once you can find Corvus, and you can find the Stargate Cluster, the Sombrero Galaxy is just next to it. And then there's my personal favorite galaxy, the Centaurus A or Hamburger Galaxy. It's right next to Centaurus, quite an easy one to find, and you can identify it immediately by seeing the black little patty in the middle. And its center contains a supermassive black hole. It's what's known as a radio galaxy because it's very radio noisy and it has regions of high radio emissions. So this allows us to observe it at greater distances. I think this is one of the objects that Meerkat is studying. And this one's a very nice one because if you know where Omega Centauri is, and you can draw a square from Omega Centauri to Altair, to the 2 little stars to the right of it, and you complete the square, you like your algebra, complete the square. Hamburger Galaxy or the Centaurus A Galaxy is right there. Also, very, very nice one to find. And then obviously, then of course, then there's other faint deep sky objects that we can see in the southern hemisphere, such as the Dunkard Nebula, which I mentioned earlier. Thors Helmet, also a very nice one. I haven't personally found Thors Helmet yet. That's on my list of objects to find. And then the Black Eye Galaxy. Black Eye is nice because you can see that it gets a nice shiner underneath. And then I just want to mention a star that's quite special to the observatory is Proxima Centauri. Now, it's the closest star to Earth at about 4.25 light years away. It's what's called a red dwarf. So it's quite small and it's quite cool. And it's extremely faint. When I checked, it was at magnitude 10. It might be, but it can go right down to magnitude 15. So I don't know if we will see it. I doubt we will see it in Magaliesburg, unfortunately, because it is very, 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 very faint and it's very, very, very small. But we can try. It's only 12.5% the size of the sun, but it is 33 times more dense. So if you picture the sun as a tennis ball, then Proxima Centauri would be a small weight of lead. Very, very, very dense. It was discovered by Robert Innes using the Franklin 10-inch astrographic camera in the Johannesburg Observatory in 1915, but at that time it was known as the Union Observatory. And observatory, for those of you who don't know, was named after the observatory. And then Robert Innes later built our 26-inch refractor telescope in 1925. So it will be turning 100 in 2025 to continue because he specialized in faint binaries. And he then went on to discover at least like 1,600 pairs of these stars. So we are known for this particular stuff. Okay, so I'm sure you guys are all wondering, but okay, how do we, that's all fine and well, but I'd like to buy a telescope. So you get 3 types of telescopes, apart from binoculars. You get your Newtonian reflector telescopes, which is very, very simple design. It's a tube with a primary mirror. So it's a large parabolic mirror. So it's a mirror with a curve at the bottom of the tube, which then light will come in, bounce off the mirror, and because it's a parabola, it will focus the light into a point into a secondary mirror near the top, and then that secondary mirror will then focus the light into your eyepiece. So they're the long tubes that you look at from the top. What's really nice about Newtonians, they're very affordable for their size. They're what we call light buckets. Because the mirror doesn't give any distortions like a lens would. They're very sturdy. You can mount a camera onto the eyepiece, so it will stay still. The disadvantage of a Newtonian is that they can be quite bulky and heavy. They need what's called collimation to align the 2 mirrors, which can be a little bit tricky. And you might struggle to find a tracking mount, especially if you have that telescope I showed earlier. That's called a Dobsonian telescope, because it's named Dobsonian because of the mounting, the mount that it's on. So like myself, if I wanted to track, I have to build my own tracking table. I won't be able to buy one. But if you are starting out in astronomy and you want to go big, I 100% recommend a Newtonian or a Dobsonian. Best value for money. The next type of telescope is what we call a refractor. So that's the telescope we're all familiar with. It will have a primary objective lens, which is the lens in the front. And if it works like your glasses or like your binoculars, will then focus the light down into the star diagonal at the bottom. There might be a second lens near the base there. Focus it into your star diagonal and then into your eyepiece. What's nice about them is that they're small, they're light, they don't need collimating. You don't have to worry about any mirrors shifting when you're driving on dirt roads, and they give very good contrast and sharpness. The downside to refractors is that they get expensive. They get expensive very quickly. The bigger you go, the more expensive the more expensive they get. And you can get a phenomenon called chromatic aberration. It's where you get light fringes on the edges of your objects. It's particularly pronounced on the moon. I know my one pair of binoculars, you can sort of see it shows like a green magenta edge. So that means my mirrors have shifted. And then of course the amount of light that you get is limited by the size of your lens. And then you get the third type of telescope known as the Cassegrain. So there's several designs. You get a Schmidt Cassegrain or a Maxitov Cassegrain, but they're all sort of similar. And how it works, so it's almost like the marriage of the Newtonian and the refractor together. So you have a lens in the front, as you can see there. Then there's a mirror in the back, so the light will get focused by the lens, bounces off the mirror, and then you can see that disc in the middle, that's its secondary, and then it goes straight into the back, into your eyepiece. Very portable, very light. I know our curator of instruments has he bought a Schmidt Cassegrain and he takes it everywhere he goes. Very powerful given their size. And professional observatories will use a variation of this. The biggest downside is that they double in price. They double the price of a Newtonian for the same size. And they might need occasional pollination. But one nice thing, what I've noticed with the Cassegrains is that they also a lot of them come with the go-to options, which means you can once you've aligned it, you plug in coordinates, or you plug in the star you're interested, and it will find the star for you, which is very, very nice. Very nice, especially when we're doing outreach. Okay, so it's all fine and well, but how do we go about buying one? So there are a couple of things you need to consider. And this is the questions we always ask, because this is the number one question we get asked, is, are you planning on taking it with you on trips, or will it stay at home in a designated spot? Because size does matter. What is your budget realistically? Now, 1,000 Rand, not going to get you much. But so you have to ask yourself, how much are you willing to spend? Would you like a go-to option? Or are you like me and find a lot of joy in finding the star yourself? Do you need it to track? Or are you willing to build your own tracking mount? Because the Earth is always rotating. This is particularly important if you're considering doing astrophotography. Tracking is like non-negotiable unless you're willing to stack thousands of images. And then what kind of mount are you comfortable with using? So you get two main kinds of mounts. You get what's called an alt-azimuth mount, and that's your typical camera mount. It will up, down, left, right. Very easy to use. But it can't do any tracking, and it doesn't follow the rotation of the Earth. You then get the other mount, which is what we call the equatorial mount. It uses the two coordinate systems of right ascension and declination. So it will follow the movement of the Earth. So right ascension, I always tell people, is right ascension, and then declination is up and down. So you will set it to your right ascension first, and then you'll set your declination, which will be your latitudes. A bit of a learning curve when using them, but once you are comfortable using them, they're quite easy and they're quite intuitive. But they're very expensive, that's the only problem. And then realistically, what are you hoping to see? Do you want to do planetary work? Do you want to see the faint and fuzzies? Are you happy with seeing, the clusters and globular clusters and open clusters? So ask yourself, even if you want to see everything, realistically, what are you happy with? But this comes with time and experience. So my recommendation is, I'm very happy with my Newtonian. I highly recommend getting a Newtonian. There's some very, very decent brands out there, and Newtonians, as I said, they're a lot more budget friendly than your other options. But what we also tell people, if they're not sure, is come to our stargazing evenings and have a look, because we have a whole range of different telescopes that people bring. I mean, I'm sure you guys have seen my astro binoculars. Chris will have his refractor. There'll be a couple of guys with their big Newtonians. And you look through people's eyepieces and see what it is you like. Okay, so how to buy one. So the number one thing I can recommend, avoid the telescopes you find at Cape Union Mart. They tend to be crap. They're not great. They are brands we don't know. They tend to be the cheap Chinese brands. They're very flimsy, they break. And it's unfortunate when you buy it and then you look through it and then it's like it sort of kills astronomy for a couple of people as well. So
the need for spying in your neighbors.
yeah, and for maybe a bit of bird watching, but even then, I'm sure you guys know. So rather purchase from a reputable dealer or camera shop. I bought my Dobsonian from Camera Land in Sandton. The guys there are very, very nice, and they tend to be quite knowledgeable. And yeah, as I said just now, like if you don't have a scope, you're more than welcome to come to our stargazing evenings and have a peep through our ones and our members' scopes, and ask questions. And we've got one member he said to us, I want to buy a scope, I'm coming, I really want to. And he comes to every single stargazing evening because he says he wants to buy a scope, but he's not willing to commit yet. So I said, come. So, and now you can see the wheels turning, he's starting to make up his mind which one he wants, which is the Schmidt-Cassegrain. And then if you join our society, so I'm going to plug our society a bit here. If you join our society and you come to regular meetings, we also have scopes out on that we're willing to loan as well. If you don't want to quite make the commitment, but you'd like to gain the experience of using a scope. And then also secondhand is an option. There are some very decent secondhand scopes that we have found that people approach us with. Just be sure to inspect the scope, make sure there's no scratches. Make sure if it's a Newtonian, make sure there's no damage to the mirror. But Newtonians tend to be quite durable. That's why I love them. If it's a refractor, make sure that there's no scratches on the objective lens, on the lens in the front. Stuff like that. It's almost like buying a secondhand car. You make sure that the main parts are working. And if you're not sure, you're more than welcome to bring it to ESSA, and we can inspect it for you. And then, of course, there's always the option of selling your first scope and upgrading it. So if you buy a smaller scope because you want to test the waters, that's fine. You can always sell it and buy bigger later once you have a better idea of what it is you're looking for. I did that with my eyepieces. Where we went to Bloemfontein, because I've been in two minds about what eyepiece I want to buy for my 10-inch. And I realized throughout that whole weekend, I wound up using the eyepiece that doesn't have as high magnification, but it's got a very wide field. So, when you look through it, it's almost like a portal to heaven. You can see very nicely. And then I use what's called a Barlow lens, which is a type of lens that you stick on the end of your eyepiece, and then you put it in into your telescope. And what it does is that it adds a bit of magnification to your eyepiece, your existing eyepiece. So what I wound up doing was I used my 40mm focal length eyepiece with my 3x Barlow lens, and that was all I used the entire weekend. Because I was interested, I was doing galaxy hunting, so I wanted to see the galaxies. Because the one thing with magnification, which I'll get to now, one thing with magnification is the higher your magnification, the less light will be let in. So magnification doesn't necessarily mean better or clearer views. But I'll explain once I talk about eyepieces in a second. We're nearly done, don't worry. And then obviously trust it with a good brand. So Orion, Meade, Celestron, Skywatcher, Teleview, those are very decent brands. Skywatcher in particular, they cater to they have the more affordable telescopes, but very decent quality. I must say, I was told at Bloemfontein by by Johann Smith, the chair of the Pretoria ESSA, and he said you've got a very decent scope there. So Skywatcher, I highly recommend. But if you can afford Orion or Celestron or even Teleview is sort of like the Lamborghini Rolls Royce. If you can afford those, then awesome.
You haven't mentioned price.
Okay, so I can tell you when I bought my Skywatcher. So mine's a Skywatcher 10-inch Dobsonian. It's the classic 250p. So it doesn't have any tracking. It's got nothing fancy on it. But because it's 10 inches, it's a light bucket. I paid about 18,000 Rand for it, which is not bad for a scope that size. I was looking at similar scopes for Orion, and I think at the time Orion was going for about 30,000. And then of course, once you start adding your computerized go to German equatorial mounts, then that adds to your price. So you have to shop around, and you have to sort of ask yourself, what is it you want to see, and how much am I willing to pay for it? So I like doing the deep sky faint and fuzzies. I like doing planetary stuff, but because my scope doesn't track, it's quite difficult to keep it on a high magnification on a planet. Whereas I get the most joy of looking at galaxies. So I purchased my setup for that. Good job. And then
before you come off prices, can you give us a relative comparison of the trading versus refractor versus Cassigrade?
Okay, so 100% cleared up on the prices of the others. So I paid 18,000 for my 10-inch Dobsonian. They're much cheaper as you go smaller in size. I think the 6 inches are going for about 10, I think. Then your refractors, if you're getting a Celestron, I think Chris might have to help me out in this one as well, but your refractors, depending on the size of your objective lens, you're looking at anything between 20 and 30,000. Your Schmidt Cassegrain or your Maxitov Cassegrains, the one that our curator John has, I think he paid upwards of about between 35 and 50 for his, but his is completely computerized. He uses it for astrophotography. He punches it. It's great for outreach because he just punches in, like M35 and then finds the star for him.
So by way of comparison,
Sorry, guys, our Zoom audience can't have a question, so let's.
Oh, they're asking. No.
Few questions afterwards.
Okay, all right. And then so last but not least, is eyepieces as well. So an eyepiece can make or break your experience. And as I mentioned earlier, I only decided on my eyepieces quite recently. So I spent about a good 8,000 Rand on an eyepiece this big and its Barlow lens this big. And the one arrived today, the other one's arriving next week. So I'll let you guys know on the 22nd how I fared. But rather invest in a few good quality eyepieces than get those kits of 10 mediocre or, not so great eyepieces for 2,000 Rand. And of course, remember, the higher your magnification, the less light will come through. You see this particularly with planets. You start losing the detail as you get in closer. And you must also, you can only push the magnification so far as well. Your scope can only, you have to look at your focal length of your telescope to see how much magnification you can put on it. But and then of course, like with magnitudes, the smaller number will mean a higher magnification for shorter focal length. And then and then of course, more than welcome to come to our staff parties and our meetings and bother us with questions. No question is too dumb. We love answering questions. And that's my email. If anyone wants to come and join and ask me questions. Thank you.
Excellent, thank you.
Right. Stop sharing. That now.
Not at all. There we go.
Great.
Excellent.
Alison, thank you so much. What a fantastic, what a
Sure.
fantastic.
It's a lot for people to
Yeah.
take in.
No, but it's mind blowing. I must say, I expected a little bit more on horoscopes, but
Liar.
we're a little bit pressed for time. We're on our way to supper at the country club, but let's take one or two questions. I think, Brendan, you were trying to ask something. You're okay? We'll chat about it afterwards. Anybody else?
I see Chris has a question.
Let's go to our Zoom audience. Lewis, can you just take us through some of the questions or comments there?
No, they're too complicated. Alan Smith asked about binary stars, how many, and whether nebula are inside galaxies or galaxies on their own. And Chris answered most of that stuff. So if anybody's interested, I can save the chat and email it to them.
Yeah, I think that'll be great. And we have recorded this, which will be up on our YouTube channel in the next couple of weeks as well. So I think let's leave it at that point. We are a little bit pushed for time. But Alison, thank you so much. There you go. And if anybody or everybody on the Zoom audience, if you wouldn't mind turning your cameras on for 5 minutes, if you dress decently, let's just, or 5 seconds, let's just turn our cameras on and give a warm round of applause to Alison, because that was really something quite special.
Thank you.
Really enjoyed that.
Great, everyone. Great to see you live. Great to see you online. Please come and join us for the ESSA trip in Magaliesburg on the 22nd. Get a chance to see the stuff in the flesh. We've done it for many years together with ESSA. It really is a special outing. Indeed, and the poikies also help a little bit as well. Okay.
And we will have our scopes there as well. So if you want to ask us about our scopes and you want to have a peek through, please come through.
Fantastic. Okay, everyone. See you,
Thank you.
up on the trip next time. We'll and a big thank you once again. Okay.
Pleasure.
Cheers, everyone.
Thank you.